Good morning, everyone. Today we are going to discuss part 2 of model number 5, that is IoT physical devices and endpoints. The main concept we are going to learn here about the Raspberry Pi. This is the outline of the session. Starts with the introduction to the Raspberry Pi. We are going to learn about hardware layout, what is the operating system is going to use for the Raspberry Pi, then how you can configure Raspberry Pi, to boot the operating system or to work with the Raspberry Pi for different applications. So at the end we're going to see that how we can program the Raspberry Pi for certain applications using Python. So Raspberry Pi is a small single board computer that mainly used to connect variety of peripherals for particular type of applications. So it's very popular because it's having image and video application processing, and so nowadays it's going to use for IoT based application also, and it's also used for audio applications like a lot of applications we can able to do with the Raspberry Pi. So Raspberry Pi Foundation officially provides a Debian based Raspberry OS. So it's a OS look like Linux environment. So most of the things are very secure here. So this OS is continuously updating on a monthly basis or quarterly basis. Now Raspberry Pi OS is officially operating system available free of use. You can easily download and you can install in the Raspberry Pi circuit kit. This OS is efficiently optimized to use the Raspberry Pi. So Raspberry Pi also having some of GUI where you can go for browsing. Some of the programming language you can learn here, and some small scale gaming are possible. So due to the limitation in the hardware part like CPU and memory, so you can run small scale applications that consume the less memory power. Then we should use the SD card. Minimum 8 GB is recommended to store the operating system. Raspberry Pi is more than a computer as it provides access to the on-chip hardware (GPIO) for developing the variety of applications. By accessing GPIO, we can connect a lot variety of devices, sensors, motors, actuators to control them for certain application. It is having ARM-based Broadcom processor. ARM-based means advanced RISC machine. So based on the certain specification, this is developed for the small scale, and it is a RISC-based machine means all instructions are very limited here. Then the clock speed of Raspberry Pi varies from that 700 MHz to 1.2 depending upon the type of board. There are variety of boards available. So certain boards having less CPU speeds and certain having the highest CPU speed. So this is a layout of Raspberry Pi board. So it is having that micro SD card. So you can use for installing the OS, and certain applications you can store the images. If you are attaching the camera, it is also helpful for storing some images, audio and video. And it is having micro USB power supply. Whatever you are using for mobile phone nowadays, that my USB power supply you can use here. It is having two HDMI ports to connect the different output devices. Then it is having camera module also. So to connect the camera, I need to use that this module. Then I am having the audio jack. So to connect the audio jack to connect earphones or speakers, this audio jack is going to help for them. Along with this, we are having the two USB ports nowadays. In some Raspberry Pi, we are having four also. Then it is having the one Ethernet port to connect to the your Raspberry Pi to the some other LAN networks. It will be very helpful. Then it is having 40 pins of GPIO. GPIO means general purpose input pins that mainly used to connect the electronic devices like sensors, actuators, etc. So these are various versions of Raspberry Pi. Raspberry Pi models: B plus, A plus, Model B, Raspberry Pi 3 of Model B, Raspberry Pi 0. So all are having different configuration, different features. So if you see that the most of the features are same, but thing is that some CPU frequency and processor, SoC and storage is a little bit changed here. And then you can see that here in the Raspberry Pi 0 is initial model that doesn't have any Ethernet connectivity as well as wireless connectivity. So apart from this, all are same here. Only thing is the certain specification about the CPU and operating speed. These are the images of various Raspberry Pi models. Raspberry Pi 0, so that built initially, then Raspberry Pi board, Raspberry Pi 3 Model B hardware. So there are some components available in the Raspberry Pi. These are HDMI that mainly used to high definition multimedia interfacing. You can connect these Raspberry Pi to video and digital audio to transfer data to the computer monitor, digital TV, etc. CSI camera interface to connect to the some certain cameras, Broadcom processor as well as cameras. It can be helpful for the connecting the cameras. DSI display interface that mainly used for connecting LCD to the Raspberry Pi using 15 pin ribbon cable. DSI provides fast resolution display interface specifically used for sending video data directly to the GPU to LCD. Then it having composite audio output, so where you can having the AV to send the data to the to stream the data to the various devices. Then power LED, this it's a red color LED which is used for the power indication. This LED will turn on when power supply to the Raspberry Pi is given. It is connected to 5 volt directly and will be start blinking whenever supply voltage drops to below the 4.63 voltage. Then actual power, the actual power is a green which is already which shows that SD card activity. So whenever you want to store or access the data from that SD card, this will be blinking at that time. The next topic is about operating system on Raspberry Pi. So Raspberry is a very popular operating system that is used for specifically for Raspberry Pi. So it was initially built, was completed on June 2012 by Mike Thompson and Peter. Raspberry Pi uses the Pixel concept, like Pixel desktop environment. Pixel means Pi improved X Windows environment with a lightweight. It's a lightweight application. So it's a lightweight desktop application that mainly used to GUI desktop to show the user and it's easy to interact with the user. The operating system still under the development, so the developers are trying to optimize the operating system to consume the less memory as well as less CPU power, and it is using the ARM based CPU. ARM is advanced RISC machine CPUs that mainly used for the certain applications only. So continuously it is optimized for the giving high performance. These are certain features about OS. So developer is Raspberry Pi Foundation. Families like Unix operating system, Unix and Linux. Source model is open source. You can download free of cost. You can have your own models. You can upload to the developers. Then research release is as per my knowledge is 16.02. Since 2017, in now 2020, there may be certain latest release also available. So marketing target is Raspberry Pi people, means Raspberry Pi customers. So where customers can have their own applications like CCTV camera and certain small robots, playing gaming robots like that. So to update the tools, I am going to the method is APT. APT means advanced package tool. So you can see that APT is a command used in the Linux also. So to update anything, to install anything, I am going to use that APT command. So package manager, so dpkg is one of the package manager that mainly used to install or uninstall the various packages from the OS. Platform is ARM, advanced RISC machine. Then kernel type is monolithic. So monolithic means it's a very limited capacity that controlled in a same way. User land is GNU, default user painter is Pixel, and license is free and open source software license. Official website is raspberrypi.org is the website. So these are various operating system I can install on the Raspberry Pi. So these are lightweight operating systems that can be used to certain applications. So these can be installed in the Raspberry Pi. So we will not discuss much more about these operating system. So what are the software management on Raspberry Pi? So there are certain commands to update, to upgrade, to install certain modules or tools in the Raspberry Pi. These commands can be used. Update is used for updating the certain applications or certain packages. Upgrading means complete tool you going to upgrade it. You are going to go for a new version like that. If you want to install certain application, I go for the install. To download the specific applications from the internet, I can use the download. To remove the data from to remove the certain tools and packages from the Raspberry Pi OS, I'm going to use that remove. Purge is also used for the same purpose. Then distribute upgrade means is distributed the upgrading the all types of tools that are used in the certain applications. So these are the variety of programming languages that are used to develop the certain application in Raspberry Pi. So Python is recommended because it's having so many advanced or predefined packages are available. So C, C++ a little bit difficult to code here because not much of the predefined functions available in this. Java is also okay. Scratch is also okay. Python and Scratch are Java are two more popular languages for the Raspberry Pi. So most of the nowadays, most of the people are referring or recommending that Python. So come to that Python programming for Raspberry Pi. So how can I code the programming? To understanding the coding part, you should have some programming language about Python. So Python is not a very difficult language. It's easy to use programming language. So anybody can code the Python. But thing is that we need to understand that different configuration of Raspberry Pi, different pin structure of Raspberry Pi. So to connect various devices to the Raspberry Pi, the GPIO model, general purpose input output pins are very essential to understand. So here there are 40 pins are available, each and every pin having its own specification, its own advantages to connect certain sensors, so to connect the LED, to connect the PW, PMW. So many things are available. So based on my application, I can use a certain application. So we can give a variety of power supply here, 3.3, 5 volt, and so many grounds are there. So you can utilize all these for supply, take for power supply. Other pins can be used for certain applications like connecting cameras, connecting audio video, so connecting AVA. So these things can be used for the things. So there are two modes here. Now main thing is to write the program we need to have some initialization. So where initialization I have having two modes to specify the pins in the program. So main thing is it's all about that specifying the pins, which pin I am using for the particular application. So how can I refer that pin? So that I am having with the two different modes here. One is board mode, other one is BCM mode. So board mode is referring that just pin numbers like whatever the equivalent circles. No, you can use these numbers to indicate the certain pins. Now in a BCM model, you can use these rectangle values. So values in the GPIO 23. That is a pin number 16. So in board mode, I can use the 16. In a BCM mode, I can use the GPIO 24 for referring the pin or to representing certain pins in the GPIO model. This is a small program where I can use to blink the LED. So there are some certain packages are required here. So these are the packages are RPI, Raspberry Pi, GPIO package. This is available here. First you have to install the package and import it as a GPIO. So now I need to take some time package because I'm going to use the delay function here. To use the delay function, I should use the time. Now, as we seen here, we are going to use that set mode is GPIO.bcm. So, GPIO.bcm, this you can refer the pins with the numbering also. So now setup. So setup means, so how can what pin I am going to use for what is the purpose? So there are two parameters we need to pass here. What the first one is pin number, second one is whether it's input or output. Pin number is act as the output because LED is the one type of output device. So I am setting that 8 pin number 8 is for the output. So this program will continually execute until unless you turn off the Raspberry Pi. So while true, GPIO dot output. So what is the value I have to pass here? Output as a 1 means that, so output having two values. What is the pin and what output value are going to pass? So pin is 8 because I'm using the pin 8 for the LED. So if I pass as a 1 means the LED will be on. After some time I'll giving the delay for 1 second. After 1 second I'm calling the function again with the 8 and 0. 8 and 0 means for 8 pin we are passing the 0 value means that the voltage will not supply at the time, so it automatically LED will be become off. So this is a small program I can use to do the LED blinking. So another program I can use with the button. Using some button I can write the program. So here I need some other packages here. So what I'm doing here, just set mode is BCM. So BCM means what you are telling that we are going to use the pin numbers. So first I'll set that setup. 25 is for GPIO in. So that is pin number 25 is connected to the button. Button means when you push the button, LED should be on. Once again, if you push the button, LED should be off. This is a push button I am going to use here. Then 18 is used for the LED, so that is the output device. So initially the state is false, means initially nothing is blinking, LED is not blinking. So then I am going to write down function def toggle LED of pin. If state is equal to not state, then GPIO pin output is pin dot state. Now I will try to execute this program continuously. So if GPIO dot input of 25 is true, toggle LED pin. So what the meaning is that you are putting the LED state to a different value. So in a push button is one type of button. It is having only one button. As you see in electrical switches, they are having two values on and off, but it indicates as a only single one. Within that same button, I can turn off and on. So it's like a toggle button. When I push the first time, it's on. When I push the second time, it will be off. So GPIO dot input is equal to true. So what should I do is I will be on. If input value is passing, I have to keep LED on and give some time. After that, I have to call the exit function, because I also use that exception handling in the Python. So try and accept with the use for the handling the exception. So this is all about the two programs. One is the LED, another one is LED with the button. You can get so many programs on the internet. You can refer them, but in the examination point of view, they may ask only smaller programs. Don't go for the longer programs. So this is all about the Raspberry Pi that mainly used to connect different type of sensors, machine motors, actuators for certain small scale applications. Thank you.